Hello everyone, I'm going to present the paper with the following title, Using Smartwatches to Understand the Relationship between Construction Workers' Travel Distance and Time Spent on Direct Work. The authors of this paper are Pérez, which is me, Salling, and Wandahl. We are part of the Department of Civil and Architectural Engineering at Aarhus University in Denmark. The presentation is going to follow the same structure as the paper. Let's start with the introduction. Among the different possibilities of Construction 4.0, one is to use sensors or trackers to measure workers' activities to understand how workers spend their time on construction sites. Several technologies approaches exist to automate data collection on workers, mainly related to two kinds of categories, computer vision-based technologies and sensor-based technologies. Sensor-based technologies using body-worn sensors have gained greater attention for monitoring construction activities among researchers. They use inertial measurement units or also location-based sensors, like the famous GNSS, the Global Navigation Satellite System. However, most of those types of approaches require extensive data training and also extended data analysis periods and are challenging to implement by practitioners. This motivated the authors of this paper to select smartwatches for understand outdoors worker positions. The present study presents the following research question. Which is the relationship between travel distance and time spent in direct work? The reason for trying to answer this question is because maybe in future studies we can measure time spent on direct work indirectly by measuring travel distance. Let's talk about the work sampling studies that use digital technologies. The work sampling technique consists of a statistical approach based on random observation to understand how efficiently the labor uses its working hours. However, the work sampling is time-consuming and based on manual data collection. For that, new efforts have been focused on automating this process using sensors. For that, they are trying to associate selected work categories with new indices. For example, they are looking for work category recognition, looking at worker physiological signals. For example, looking at heart rate, workers' movement, looking at hands and arm movements. So now we are looking for new ways to measure direct work based on other indices that can be easy to recognize and also to table for data collection, like for example looking for walking and transportation activities. Regarding the research methodology, we adopted exploratory case study as our research method. We conducted the case study in the city of Odense in Denmark. It was a building renovation project consisted of around 20 buildings. Each building presents around 2 to 4 floors, totalizing around 600 housing units. The construction process that we studied, it was the processes made by the carpenter trade, which involved 22 workers. The main activity conducted by those workers were remove and construct new internal walls, ceilings, windows, and balconies. The research design presented 4 stages: data collection preparation, gathering data, collecting feedback from workers, and results analysis. Talking in detail about each stage during the data collection preparation, we conducted a meeting with managers in the job site. During this meeting, we defined the trade observed, it was the carpenter, the period of the visit, weeks 25 and 26 of the last year, and also we selected the smartwatches for collecting the travel distance. In that case, it was the Garmin for running 45. Following with the second stage, during the gathering data process, we use the work sampling technique to understand the time spent in 6 work categories, those being preparation, direct work, transportation, walking, talking, and waiting. We use the TaliaCount app that I'm using here in this picture to record observation with a stamp. Continue in the gathering data stage, we adopt smartwatches to collect workers' travel distance. For that, we developed a protocol to use the smartwatches. The first activity of the protocol consisted on the selection of participants. In this case study, 10 carpenters took part of the study. Then we set up the smartwatches, which consists on insert the futures of the workers. Then we proceed with the data acquisition that is related to workers wearing the smartwatches on the job site. We can see in this video the activities conducted by the workers, or mainly where they were, and also the last activity was the data cleaning. In the third stage, we collected feedback from workers. For that, we adopted a questionnaire using the Likert scale from 1 to 5. The questioners were interested to understand if wearing a smartwatch impacted on their daily activities or not. The last stage consisted in results analysis for understanding the relationship between the travel distance and time spent on direct work. After downloading all the activities from the smartwatches, we could understand the total travel distance at the end of the day and also the average of the total travel distance in each interval of 30 minutes. So at the end, we have 16 data points. Each point represents the average of the total travel distance and the time spent in each category in intervals of 30 minutes. Moving to findings, let's see the results of the work sampling technique application. The Tally account app allowed to us to have the time stamp of each observation, so we could see the evolution of this time spent on direct works along the day. So at the end, we get that 29% of their time workers spend on product activities. So we can get the data point of each interval of 30 minutes to compare with the distance that they travel in those intervals. Regarding the findings of the smartwatches, we can see in these figures that after 9 days of data collection, we can collect the average travel distance between intervals of 30 minutes. Each column represents each smartwatch. We grouped all this information in a new figure, and we can see the average travel every day. So if we focus in the first interval, we can see the average it was in that period about 0.4 kilometers. So having in mind the distance that they travel in each interval and the share of time that they spend in each work category, we can correlate those data points for understand the relationship between each travel distance with each category. So we can see that we found an interesting correlation between distance and production. Different as we expected, the correlation is a strong correlation. It means that the more they travel, the more productive they are. Finally, we were interested to understand workers' perception of wearing a smartwatch. For that, we conducted the questionnaire, and we can see in the answer that they feel that wearing a smartwatch didn't impact in their ethical values, and also they didn't feel that interfered in their works. One of them also even said that it was fine wearing the watch and I will use in the future. Which are the conclusion of our work? Well, regarding the novelty, we presented an hybrid approach for measuring direct work which combines a consolidated technique as the work sampling, a new index that was the worker travel distance, and also a new technology using the GNSS from smartwatches. Also, our study presented several limitations, mainly regarding the setup process, because we didn't use the physical features of each individual. We adopted the average of a Danish male. Also, we realized that some workers conduct their activities inside, so the GPS could collect some errors because the indoors activities. Finally, we have several next steps in our mind. We are conducting new case studies and new construction projects, mainly related to renovation projects because they conduct most of the activities from outside. Also, we are looking for new indices, like for example, workers' geographic location. Instead of looking at the distance, now we are looking for GPS coordinates. And now for that, we are looking for new approaches. We are using Python programming to classify the GPS positions into workspaces. And that's all. Thank you for your attention.